Hello and welcome in the subject mechanical system design. We are discussing about the design of various components of IC engine. So today we will learn how to design a crankshaft, which is an important component of the IC engine used to transmit the power or motion. So the center crankshaft of top dead center position we are going to design. So while designing the crankshaft, we have to make some assumptions. So first assumption is the engine is vertical and the crank is at the top dead center position. So that is the first assumption that we have to consider while designing the crankshaft. Second, the belt drive is horizontal. That is the second assumption that we have to consider while designing the crankshaft. Then third assumption, the crankshaft is simply supported on the bearing. That is a third important assumption that we have to take into consideration for designing of a crankshaft. So first we have to calculate the bearing reactions. Let PP is the force acting on the crankshaft in Newton. Then D is the diameter of the piston. Then Pmax is the maximum gas pressure inside the cylinder. W is the weight of the flywheel. P1 is the tension in tight side of flywheel. P2 is the tension in the slack side of belt. The small b is the distance between main bearing 1 and 2. And C is the distance between bearing 2 and 3. Therefore, for or at top dead center position, we have an equation PP or the force acting on the crankshaft is always equal to the area into maximum gas pressure inside the cylinder. So the formula will be PP is equal to pi by 4 d square into Pmax. Therefore, diameter of piston is 100 mm and maximum gas pressure is 3 Newton per mm square. Therefore, putting the value, will get the force acting on the crankshaft, which is equal to 23,561.94 Newton. So this is the calculation of the force acting on the crankshaft. Now, next assumption is that the center to center distance between the main bearing 1 and 2 is twice of the piston diameter. Therefore, the center to center distance B is equal to 2 times the piston diameter. So the center distance between two bearing 1 and 2 is equal to B is equal to 200 mm. It is the further assume that B1 equal to B2 equal to B by 100. Therefore, 200 by 2, that will be 100 mm. So B1 and B2 equal to the 100 mm. So by symmetry, reaction R1V is equal to R2V is equal to PP upon 2. So we will get the reaction forces as 11,780.972 Newton. So this will be the calculations for the reaction forces. Similarly, it is assumed that C1 is equal to C2 by symmetry. Therefore, R2-V is equal to R3-V is equal to W by 2. Assume weight of the flywheel is same as the weight of the flywheel cum belt pulley. So which is equal to the 1 kilonewton. And for total belt pulley, it will be equal to the 2 kilonewton. Therefore, the width of the hub for flywheel cum belt pulley is equal to 200 mm. Then the torque on the crankshaft is maximum when the crank turns through a 25-degree from top dead center. The belts are in horizontal direction. So this is what torque is maximum when the crank turns through 25-degree from the top dead center. And the important condition is that your belt direction is a horizontal direction. Now this is a diagrammatic representation of the crank. You can observe this is a crank. Then this is a shaft, and these are the bearing. Then this is a crank wave. This is a crank pin. Then this is a diameter small d 50 mm. Then length will be 300 mm, LS plus LB. then radius r is equal to 65, then bw width is equal to 64 mm, then diameter of crank pin is a 55 mm, then thickness of web is equal to 40 mm, etc. So this is what crank pin and crankshaft dimensions or diagrammatic representation. So we are calculating the reactions which will come as a 500 Newton, and in vertical direction it will be 500 Newton, and in horizontal direction it will be 1000 Newton. Next will be design of crank pin. So we have to assume that allowable bending stress for crank pin is 75 Newton per mm square. Then allowable bearing pressure for crank pin bushing is 10 Newton per mm square. Suppose DC is the diameter of the crank pin. So we have to consider assume the diameter is denoted by the DC for the crank pin, and length of the crank pin is denoted by the LC. The center plane of crank plane is subjected to the maximum bending moment. The bending moment at the center plane is given by MBC is equal to R1V into B1. So putting the value, you will get the bending moment of crank pin 1.17 into 10 raised to 6 Newton per mm. As MB is equal to pi by 32 DC cube into sigma B. So from this, what we putting the value, what we get the DC cube is equal to the value of 1,59,999 mm. So the DC will be equal to 54.28 mm, and the round figure of the diameter of the crank pin is equal to the 55 mm. Then assume the L by D ratio for crank pin bearing is always 1. So L by DC is equal to 1. Therefore, L is equal to DC is equal to 55 mm. So checking of the crank pin design, that is nothing but whether that stress or design is safe or not. So PB is equal to PP upon DC into LC. So putting this is the force gas pressure acting on the crank pin, then a diameter of the crank pin and the length of the crank pin. So putting all that value, you will get the PB is equal to 7.79 Newton per mm square. So the PB is less than 10. So our design is safe. Then next point is a design of left hand crank web. So assume that W is the width of the crank web in mm, and T is the thickness of crank web in mm. Therefore, the dimensions of the crank web are calculated by empirical relation and check the stresses. Therefore, T is equal to 0.7 DC, where DC is the diameter of the crank pin. Therefore, T thickness of the web is equal to 38.5 mm. So that will be equal to 40 mm round figure. Next, W width of the wedge is always equal to 1.14 into diameter of the crank pin. Therefore, W is equal to 64 mm. The left hand crank web is subjected to the eccentric load R1V. There are two types of stresses in central plane of the crank web, that is direct compressive stress and bending stress due to reaction. Therefore, the direct compressive stress is given by sigma C is equal to R1V upon W into T. So by putting the value, the direct compressive stress is equal to 4.60 Newton per mm square. Then second one is a bending stress due to reaction is calculated by using this formula, sigma into R1V into bracket B1 minus LC upon 2 minus T by 2 divided by W into T square. By putting all the values of stresses, then length of crank pin, then thickness of web, etc., and width of web, we are getting the bending stress due to reaction is equal to 36.24 Newton per mm square. The total compressive stress is given by sigma Ct is equal to sigma C, that is nothing but stress due to the compression and stress due to the bending. So that will be equal to the total compressive stress is given as a 40.84 Newton per mm square. So the total compressive stress is less than or equal to 75 Newton per mm square. That is allowable stress. Therefore, our design is safe. Next is design of right hand crank wave. Uh, the left hand and right hand waves are made identical for balancing consideration. Therefore, the design is also same for right hand crank wave. That is like a left hand crank wave. Next is the design of crankshaft under flywheel. The width of the hub for a flywheel cum belt pulley is given as a 200 mm square. So it is observed that for the central distance between two bearing 2 and 3 should be more than 200 mm. To accommodate the bearing, we will assume that C is equal to 200 plus margin length of the two bearing 2 and 3. Therefore, the C is equal to 300 mm. Therefore, C1 and C2 equal to half of the C. That will be equal to 150 mm. Let ds is the shaft diameter under flywheel. So we are going to design the shaft diameter under the flywheel. First, initially we are calculating the bending moment in the horizontal plane. So that will be equal to bending moment in vertical plane is equal to 75 into 10 raised to 3 Newton mm, and bending moment in horizontal direction is equal to the 150 into 10 raised to 3 Newton mm. So the resultant bending moment is the square root of bending moment in vertical direction and the bending moment in horizontal direction square, sum of square. Therefore, bending moment, resultant bending moment will be equal to 167.71 into 10 raised to 3 Newton mm. Therefore, allowable bending stress is 75 Newton per mm square. Therefore, the bending moment, the resultant bending moment is equal to pi by 32 into ds cube into sigma b. So the ds cube is equal to 27.78 into 10 raised to 3. Therefore, ds is equal to 28.35. So ds we are assuming it as a 30 mm in case number 1. Now in case number 2, crank is at the angle with the line of the dead center position and subjected to the maximum torsional moment. Therefore, component of the force on the crank pin. So the crank angle theta for maximum torsional moment is given by 25 degree. Therefore, P is the gas pressure on the piston top for maximum torque condition. Therefore, PP is equal to pi by 40 square P max. So you will get the PP is equal to 23,561 Newton. Therefore, sine of phi is equal to sine of theta by L upon R. Assume L by R ratio is 4.5. So from this you will get a phi angle 5.39 degree. Similarly, the thrust on connecting rod PQ is given as PP upon cos of phi. So the PQ equal to 23,666 Newton. So the PT and PR are the tangential and radial component of PA at the crank pin. So the PT will become as a 11,972 Newton and PR will become as a 20,440 Newton. So the bearing reactions will be the crank shaft is supported on the three bearings, that is 1, 2, 3 as decided in previous case. Therefore, B is equal to 200, C is equal to 300, B1, B2 equal to 100 and C1, C2 are 150 by symmetry. Similarly, reactions are calculated and the design for crank pin will be assumed allowable shear stress is taken as a 40 Newton per mm square. Therefore, DC cube is equal to 16 by pi into shear stress into square root of mb square plus m tau square. So putting the value, we will get the diameter of the crank pin is equal to 52.36 mm. So the round diameter for the crank pin is equal to 53 mm. So in this way, we can design the crankshaft and crank pin by using the design methods.